1.7. We're going to talk about rational numbers. Remember, rational numbers are things that are ratios, a over b, numerator over denominator. We've talked about multiplication of rational numbers, and now we're going to go to division of rational numbers, because it's multiplication and then division. They kind of go together, kind of go hand in hand. If we're talking about division of fractions or division of rationals, oops, hang on a second, I'm going to go rationals, thank you. Division of fractions is divisions of rationals or something in the form of a over b. Then essentially what we do is we multiply the dividend by the reciprocal of the divisor. A lot of words there. I like to say stay, change, flip. You could also say this is the same thing. A lot of mathy words up here. Stay, change, flip. First fraction stays the same. Change division to multiplication, and then flip the second fraction. You can also say that division by a fraction is multiplication by the reciprocal. But in any way, whatever way you remember it, that's the way you remember it. So here's an example. Divide 2/5. Divide 2/5 divided by 3/4. So multiply the dividend by the reciprocal. Here's our dividend by the reciprocal of the divisor. A lot of words. Or stay, change, flip. It's a way to look at it. It kind of helps if it's in linear order this way or in column format. 2/5 stays the same. Divide changes to multiply. 3/4 changes to 4/3, or flip the second fraction. And then we're back to multiplication. We've done multiplication before. 2/5 times 4/3 is 2 times 4 over 5 times 3. And then you look to cancel things out. Cancel, reduce, factor, simplify. There's nothing that simplifies here, so 2 times 4 is 8. 5 times 3, 15. Done. But the hardest part is right here. Stay, change, flip. First fraction stays. Change, divide to multiply, flip the second fraction. Okay, so, and by the way, reciprocal is, here's the definition of reciprocal. Reciprocal of a fraction is the fraction with the numerator and denominator interchanged. So 3/4, reciprocal of 3/4 is 4/3. 4 goes to the top, 3 goes to the bottom. So there we go. Alright, so let's divide. Let's take a look at 3/10 divided by negative 18/25. Well, we're throwing a negative in here. But essentially it's really nothing big. If we follow my stay, change, flip rule, stay, 3/10 stays, change, divide to multiply, flip the second fraction, negative 25/18. And there's our stay, change, flip. I've got now 3, well, let's see, we'll call it this, 3 times negative 25 over 10 times 18, and I'm going to say that would be also 3 times negative 5 times 5. I'm encroaching here a little bit over here in my other question. 10 becomes 2 times 5. 18 becomes 2 times 3 times 3. 3 times 3 is 9, times 2 is 18. And all we've done is factor out 25, 5 times 5, 10, 2 times 5, 18, 2 times 9, or 2 times 3. Now it's all prime factored. Look to cancel, reduce, factor, simplify any factors. 3 divided by 3 is 1. 5, or 5 divided by 5 is 1. Those factor out, cancel, reduce, simplify. What is left in my numerator? Negative 5 over 2 times 2 times 3, because 5 doesn't cancel, reduce, factor, or simplify with these guys down here. 2 and 2 and 3 don't share anything with 5. So 2 times 2 is 4, times 3, 12. Negative 5/12. That's my answer. I'm sticking to it. Alright, this is another example over here. 5/8 divided by negative 10/11. But you know what? We got more room over here. So let's divide over here. Negative 4/5 divided by negative 7/15, or sorry, divided by 7/15. Okay. Let's see, I'm going to maybe see if I can move this guy up a little bit and give us a little more space. Alright, so I've got, let's see, the whole thing would be negative. Negative times a positive would be negative. So I'm going to stay 4/5, change, divide to multiply, flip 15 sevenths. All right, now I've got negative these two, multiplication of these two fractions. We've been here before. We could just say, you know what, I'm going to go and I'm going to recall 15 3 times 5. 4 doesn't cancel with anything down here because these are not even, so I'm not going to worry about factoring 4. And now I realize that 5 cancels with 5. 5 divided by 5 is 1, so that cancels out. I got 4 times 3, and 7 doesn't cancel with either one of those. 7 is prime, and there's no 7 in 4, so now I've got my, the entire answer is negative. 4 times 3 is 12 in my numerator. 1 times 7 is 7, and there's the answer, 12 sevenths. And I could say that that would be negative 1 and 5 sevenths. Negative there. 12 divided by 7 is 1 with a remainder of 5. 1 with a remainder of 5 over 7. Done. One more example, I suppose, and if you need to not watch this example, you feel comfortable, you can always fast forward, I suppose. All right, I'm going to see if I can move this up. Give me a little more room here. There's my little more room. I got a negative times a negative, so I'm going to have an answer that's positive. I'm going to write this down here as positive, and later on just to kind of ignore the positive sign, but just because it's a negative times a negative, it's a positive, I'm going to leave it there. Stay, change, divide to multiply, flip. 11 over 10. And what I've done is taken care of the negative signs here as a positive sign. Negative times a negative is a positive. 5, 6 stays the same, change, flip. And now I've got, all right, positive, I'm going to ignore that. 5 times 11 over 6 times 10. And I'm going to say this is 5 times 11 over 6 times 10. We'll call that 2 times 5. 5 divided by 5 is 1. Those cancel out, reduce, factor, simplify. 11 and 6 don't cancel. 11 and 2 don't cancel. So 11 over 6 times 2, 12. Positive, because it's negative times negative is positive. We didn't carry the sign along, and we assume it's positive. And there's our answer, 11/12.